I'm working, I'm working, I'm working, working, I'm working, I'm working, working, I'm working, I'm working at my job.
Okay, I think I'm ready to push my changes up. Nobody saw anything.
Do it every day in exchange for pay. I'm working on a raise.
Hello? Whoa, 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 whoa. Slow down. Ransomware? But you're saying because it had read and write access to that bucket, they just replaced all the objects? My commit? No. That can't be. I did leak an AWS key, but for like a half a second, and I took it down right away. Can you show me? I didn't think people would go through the commit history like that. Do I need to be worried about my job here? I have to I'm gonna be unavailable. I have to go. I'll be on Slack. Six years ago, I authored a tool called Trufflehog that finds API keys and passwords that people post online. A lot of people started using it, and it became really obvious that GitHub.com was polluted with these types of secrets. There's now a whole company behind Trufflehog called Truffle Security that's goal is to continue to open source tools like Trufflehog to find API keys, passwords, and credentials in places that they shouldn't be. Today, I'm proud to announce a new tool that we'll be launching in a couple weeks called Forager. Forager will show you how many live keys are being posted to GitHub and NPM every single day, and it'll break them down by key type and by company. Here's the link to Forager. Now, this may just be a countdown clock to our launch date, depending on when you're actually watching this video. We learned some really cool facts while we built this tool. Like, for example, most secrets land in personal repositories, not in corporate repositories, and for some reason, Google Cloud keys leak out at a much higher rate than AWS keys. Before we get into all that though, I want to share a short story about the weeks that followed me originally open sourcing Trufflehog. Back in 2017, a security researcher named Kevin used Trufflehog to find API keys and passwords that DJI, the drone manufacturer, was posting to GitHub. He used those keys to unlock his drone so he could fly it anywhere. He could fly it over the restricted areas that DJI doesn't want you flying. The developer that leaked those keys out ended up getting arrested by Chinese authorities, and he actually went to jail for a couple of months. It was so f***ed up. Kevin turned down a $30,000 bug bounty so that he could share that story. I give a much deeper dive into that story on the Truffle Security YouTube channel and on our TikTok, so go follow us over there if you want to hear the whole story. Here's the thing though, those keys weren't posted on any official DJI repositories on GitHub. Those keys were posted to DJI employees' personal code repositories. So how on earth did Kevin know where to look if it was just on the employees' personal repositories? Okay, Git can be a tedious beast, but one of its requirements is that every single commit that you check in, you have to have an email address that goes with that commit. And that email address is not one-to-one with your GitHub account. Your GitHub account could have a whole bunch of email addresses for all the commits that it's checked into the GitHub platform. Make sense? So imagine a scenario where someone uses the same GitHub account for both their work and their personal use. If we watch that person's contributions, we can learn both what their work email address is and all of their personal email addresses, as well as the email addresses of their previous employers if their history goes back long enough. Then, once we know their email addresses, if that person ever makes a second GitHub account, we can correlate those two accounts together by the email addresses that they're both using. Following me so far? Here's the tricky bit. None of these emails are actually verified by GitHub. So all of this is just based on what someone puts as their commit email address. So it's an imperfect methodology here, but it works pretty well. GitHub has a convenient set of APIs that actually make this really easy, called the Events APIs. So here's the Events API with my account pulled up. If I scroll down, sure enough, I can see all of my email addresses associated with my GitHub account. Like, here's my college email address. Now I know what you're thinking. There are 100 million GitHub accounts. How would Kevin know which ones to watch if he wanted to find the DJI keys? Let's go back to the Events API. Instead of putting in a user ID, we can actually put in an organization. Like, for example, the DJI organization. And that will show us all the events that are associated with that organization. So if people are pushing code to DJI's organization, for example, those people, if they have write access to be able to do that push, then they probably work for DJI. So let's try it out. If we hit the Events API for DJI, sure enough, here are a bunch of push events to the organization. And then, if we hit the Events API for those users that did those pushes, we can get not just their DJI email addresses, but also their personal email addresses. See where I'm going with this? Now we can start to monitor all of the different things that the employees of DJI do across all of GitHub, not just the contributions that are made directly to the DJI organization. Like, for example, someone might push a secret to a repository that's neither under their own account nor under the DJI account. It could just be an open source contribution that they make. Or they could start a project on their own personal account and push a secret to it, or they could fork one of the DJI repositories and modify it under their personal account. There are a lot of different scenarios here that we lose context for if we're only scanning the DJI organization for secrets. But this whole new universe opens up once we start tracking together identities and painting the picture of who might work for DJI and where might they be posting source code to. Okay, so just to summarize, here's a quick script that we open source that does exactly that. It just pulls all the users out of a given GitHub organization, and then it starts monitoring all of the contributions that they make across all of GitHub, and then it'll print the standard out all of the commits that it sees happen. That being said, there's actually a second, even easier way to get this information. The Events API that we've been using so far has been targeted. We've gone after a specific user or a specific organization. Well, it turns out on GitHub, if you leave off the user and the organization, the Events API will actually just return every single event that's ever happening across the entire GitHub website. Now we can use all of the tools and methodology that we just talked about in terms of monitoring email addresses, and we can start to piece together exactly who works where and build a really comprehensive identity database for every single GitHub user across the entire platform. The last step in this process to make Forager work is just to wire all that information up to TruffleHog. Every single commit that gets checked into GitHub across the entire platform, we can see through the Events API. And then, based on the email addresses that we have associated with that username, we can piece together what company that contributor likely works at, and we can say that that given secret that that person just posted in that commit could be affiliated with the company that they work for, even though it was checked into a personal account or a fork or a repository totally unrelated to either entity. So that's what we did. And now, once this thing goes live, you'll be able to put in any organization, like Google, for example, and you'll be able to see how many secrets those employees have leaked out and what types of secrets they are. And if you work for the organization that you're searching for, then you can actually reveal the details of that secret as well. Want to know how many secrets the Russian military leaked out? Now, I know we're not the first to have this idea. How do I know that? Let me show you what happens when we actually post an AWS key on github.com. I'm going to use a website called Canary Tokens that allows you to generate a live AWS key, and will send you an email alert every time that key gets used. Then I'm going to push that key to GitHub, and we're going to see how long it takes before someone on the internet starts to use that AWS key. And the repository that I push it to is going to be a brand new repository that doesn't have any watchers, doesn't have any stars, and no one would otherwise be looking at. Okay, 10 minutes. The answer is 10 minutes. It took 10 minutes for someone to take that AWS key and start using it. And it wasn't just one person. Over the course of a couple hours, that AWS key was used over 20 times, spanning multiple locations, including the United States, Canada, Europe, parts of India. Clearly, a lot of people are subscribed to this events feed and are using these AWS keys nefariously. So for the last couple of months, we've been collecting this data, and I've got some really interesting insights that we've learned from it. On average, an AWS key is posted to github.com about every 10 minutes. 0.1% of every single commit checked into github.com has a live secret in it. Also, the average star count for a project that has a live secret checked into it is less than 1. Most of the projects that get these live secrets aren't big projects. They're small. Sometimes they're personal projects, and sometimes they're parts of an organization, but in almost all cases, they are small, unwatched projects. Okay, 7% of the live secrets checked into GitHub are part of an organization, and the other 93% are users' personal GitHub repositories. And more secrets land in the forks for GitHub repositories than in the original GitHub repositories themselves. All that being said, I think one of the coolest things about Forager is that it's ingesting NPM packages as well. Okay, let's talk about NPM. When you install a JavaScript dependency, you don't download that dependency straight from GitHub. Instead, you pull it from NPM. NPM stands for Node Package Manager. How does that JavaScript code end up on NPM? Well, it's a similar process as pushing things to GitHub. Here's the official documentation for publishing packages to NPM. It has you specifying a root directory, and then you run the push command, which will send all of the contents of that directory up to NPM as your package. Did you notice any differences between that process and the process you would follow for pushing code up to GitHub? Well, one major difference is specifying a whole directory to push up instead of individual files. Because of that subtle difference, it is way easier for secrets to end up accidentally on NPM than it is for them to land in GitHub. Like, imagine if you had an environment variable script or a test file or something that you never wanted to land anywhere outside of your computer. If it just happened to be in that directory while you were publishing, it's gonna end up on NPM, probably without you realizing it. Okay, here's a short story of when we first started looking into this. Someone had a database backup of their company's entire production database in the working directory that they were publishing to NPM. They ran the publish command, and without realizing it, they caused a full data breach for their company. Every single user, their password hashes, all of their attributes lived in that database backup and ended up in that NPM package. And the thing was, it was a few versions back, so you couldn't just download the current package and see that database. You had to specifically download the old version of the package to get that database dump. The reason we found it was because when we ran TruffleHog on all the old versions of the package, there was a secret inside that database in addition to all the user data. Immediately, we notified both the package maintainer and the company whose data that was. The package got deleted almost instantly, but we never heard back from that company. And they never did a public disclosure for the database that they had leaked out on the internet. That version of that package had been downloaded hundreds of times and was probably distributed across many different computers all over the world. Okay, that's one of the most extreme cases that we've seen, but a much more common case is just incidental files that were never meant to be published accidentally get slurped up through that directory publishing functionality that NPM has. Some of those files even came from CI systems. Imagine you had a CI system that runs some test before it publishes the package, and part of that test involves writing a file to your current working directory. That output of that test is then going to get slurped up as part of your publish command, and it's going to end up on NPM. Interestingly, NPM and Git both have their own systems for blocking these files from ending up published. But the system they use for ignoring the files are incompatible with one another. They don't work together. So while you might think that you're protected with a git ignore file that says never publish any of your environment variable scripts, that file is totally different from the npm ignore file that you would also need to make sure that environment variable script doesn't land on npm. So what are we talking about in terms of scale? Well, at the time of recording this talk, we haven't finished ingesting all of NPM, but we've already done tens of thousands of disclosures for live credentials that have landed on the NPM package manager. We're gonna publish the data in Forager at the time of our launch in a couple of weeks. And similar to the Git results, you'll be able to see all the companies that are leaking keys out and the types of keys that they're leaking out. And if you work for the company that you're searching for, you'll be able to view the raw details of what package that credential lives in and the other attributes you need to view the raw secret. If you want to try setting something like this up on your own, locally, it's not too difficult. A lot of companies internally will mirror either the entire NPM package manager or large sections of it, and that's for performance reasons so that they can do their builds faster. For that reason, there's great tools online that allow you to easily download large swaths of NPM and save it locally. Then all you have to do is run TruffleHog on those files, and TruffleHog will automatically handle all of the unarchiving that you need to do to look inside the NPM packages. NPM is the Wild West right now. No one is looking at it for leaked secrets, and a lot of the time, you end up with more secrets in NPM than the source code that makes those packages in GitHub. We're really hoping that Forager helps bring visibility into how many secrets are landing in NPM every day, and when we go live, you might be surprised to see how many companies are exposing their keys in there. Okay, so just to summarize, we've ingested hundreds of thousands of live credentials from NPM and from GitHub, and we've done some attribution to figure out which companies the people who leaked them out work for. You'll be able to search for any company that you want, and you'll be able to see how many keys that company leaked out, what types of keys that company is leaking out, and if you happen to work for that company, you'll be able to get the raw information about where those keys live. You can also pretty easily set these scans up for yourself, either by using one of the NPM package mirroring tools or the GitHub Events API. Then, after our initial launch, we plan on building out more and more integrations for all the different places that keys are leaking out on the public internet. Because trust me, the buck does not stop with Git and NPM. So make sure you're subscribed to our YouTube, our Twitter, and our TikTok, and I hope you had as much fun watching this talk as I did making it.
I wanna taste the pain. I think I'm seeing all red. 2 bullets in the gun, 1 shot.